GMGM. This is another session for our workshop, and we'll head up straight to the point to see what we have for today. Okay. All right. So in today's workshop, we're going to be looking at inside the Ethereum execution client. In our previous workshop, we spoke about the flow from the execution client to the consensus client. We didn't really dwell much to look at the details in the execution client. But in today's workshop, it's going to be very brief. We're going to be seeing one of the execution clients, which is Red. Is an implementation of the execution client with Rust programming language. We're going to see some of these components of the execution client, and we'll be looking at the code base, and we'll see how these things play out. All right. So this is Web3 Protocol Africa, powered by Guild Academy, and Nanle Nathaniel, a blockchain engineer at Web3 Protocol Africa. All right, so this is what we planned for today. I guess I need to share my screen. Oh, you're not seeing my screen. Okay. I need to share my screen. Let me share my screen now. Okay, yeah, I believe my screen is shared now. Let me start. I'm going to be looking at inside the Ethereum execution client. Inside the Ethereum execution client, and we're going to be looking at the Red client. Red client is the implementation of the execution client with Rust. Yeah, with Rust. We're going to be seeing these things and we'll explore. Yeah, basically that's what we'll do. So I'll be running down to show you the code base. We'll show you the code base. We'll do more of code base insight in this workshop. All right, so this is an outline. This is a README file I wrote just so that we can get an easy take of this. All right, so below is an explanation of each component of the RED architecture diagram, along with links to the corresponding folder in the Paradigm RED repository. So how we're going to do this is we're going to be seeing different components of the RED execution client, and I added a link that will take us directly to where this folder is in the repository, because one of the things you find difficult when you're into blockchain protocol engineering is where to find these folders. You discover that it seems as though you're looking very small in the code base. It's just because we're well explained. The code base are not well explained for us to understand. But in this workshop, what we aim to achieve is to actually begin to dive into the execution client by understanding the code base. It's very important, because when we want to start talking about writing the node initialization, we're trying to write the networking aspect of the execution client, or the transaction pool, or the EVM. We need to understand where these things are found in the code base. It's very important. All right, so this is the breakdown of the RED execution client. The first component I wrote here is we have the node initializer. So if you want to spin up a node, the aspect of the client that takes in arguments, that defines if the node is running on a network, excuse me, if the node initializer, let's just read this out. I think it will play out more better. Bootstraps the node and coordinate component initialization. So this is key function, passes CLI argument and config files. Initialize all node components, set up dependencies. So the part of the RED execution client, the part of this client that takes in arguments from a user is the node initializer. It means if you want to start to interact with a node from the infrastructure level, you interact with it via the node initializer. So if I spin up a node now and I want to interact with that node, the part of the client that helps me interact with the node is the node initializer. So I have a GitHub repo that takes me directly to where I can find this in a code base. Yeah, so this is it here. You open. Yeah. So this is the code base. for node initializer. This is a code base for node initializer, something I'm looking for. So you're looking at this code. Someone will just say, oh my goodness, what's this? You just get overwhelmed. You just get overwhelmed. This is not the full code. You see, you notice that I cut it short, but then the code base is very, very huge. Very, very huge. So what I did here is it will take you directly to where the node initializer is. And like we said in the previously, I said the node initializer helps us take arguments from the user. It takes in arguments from the user. Another part of the REDS execution client is the networking. So it manages the P2P connection and data propagation, peer discovery via DIX, V4 and DNS, transaction and blog gossip, networking protocol handling. So that part of the direct client that helps it communicate with other node is the networking. And we have a link to that part of the code in the REDS client. This would take me to one of the codes. So you're seeing this here. So this is the DIX v6. So this is a raw implementation of the DIX discovery v4, yes, peer discovery protocol. So this is the application of the networking in REST client. All right, so for comparison to discover v5, so this is all right, just quickly I'm moving forward. So the discovery service continuously attempt to connect to other nodes on the network until it has found enough peers. So the part of the red client that is responsible for networking, this is the part. Discovery version 4, right? And there are other discovery version 5 here. But this is what you need to pay attention to. Yeah, this is it here. We open the src file. So the idea now is just to let you know that I will drop the link to my repo so that anybody who wants to make it to find where these folders are in the code base can easily find his way to navigate into them. But the idea for this workshop is for you to have somewhere you can easily access these folders from the code base. It's very important we have this on ground. And the next part of the REST component is a transaction pool. We spoke about the transaction pool is where we can call it the waiting room of transactions. Transaction validation, prioritized management, EVM simulation interface, validate and manages pending transactions. So let's look at this in the code base. Okay, this is where it is in the code base. This is transaction pool, benches, this is CRS. Let's open this. This is the pool. This is okay. This is let's go to pending. So this is a struct containing the structure of what is pending pool. That's it. Order submission ID. This is where we can determine when transactions were submitted to the pool. It tracks when the transaction is submitted to the pool. This is by ID. This is highest none. So you're seeing how this works now. You can easily track a code base. If you're given a project and you're asked to work on the pool, you can fall back to this material and know where to begin with. Yeah, so this is the pending in the main pool. You can check this out after. Okay, let's move backward. So the next component I have here is the EVM, the Red Ethereum Virtual Machine. It executes transaction and smart contracts, EVM bytecode execution, state transition processing, and gas accounting. So you click here. This is the GitHub link to the EVM in red. Let's click it. So this is the EVM execution type. So all the logic that has to do with EVM, although this is, let's open it and see what's inside. Looking for where the bytecodes are. This is chains, you can find it here. This is execution.rs. So yeah, this is where the EVM is in the code base. You can explore and discover more depending on where exactly your project is. All right, another component, let's see it. So we have the state machine. The state machine, this is what helps us interact with the consensus, manages blockchain state and storage. Okay, the state machine, yeah. And then we have block headers and block storage, data retrieval interface. We click into this, find it. This is where it is in the in the code base. Um, this is storage. Let's go to provider here. Let's see. Let's go to state. So historical.rs file. Let's see what's here. State provider for a given block number, which takes a transaction reference. Historical state provider accesses the state at the start of the provider block number. So this is where everything that has to do with storage in the red execution client is found. Okay, so this again we have the consensus engine. The consensus engine. So I think in our previous class we made mention of block validation. We said there is an aspect of validation that happens within the execution client, and we said there is an aspect of validation that happens within the consensus client. The validation that happens within the consensus client is the validation where validators come and they attest the authenticity of the new block that is to be added in the network. While for the execution consensus engine, what it does when it comes to validating blocks is it ensures that a transaction is legit. You can't send the amount of it you don't have. His block is, but it has to validate that this transaction is true before it processes. So if you want to check this on the code base, we click here and then it will take us to where the code base is. Okay, so this is it inside the execution client. Let's check validations. Gas use need to be less than gas limit. Gas use. So are you seeing this checking now? So what this function does is it checks if okay gas use needs to be less than gas limit. So you are not supposed to perform a transaction that is less than gas limit. For instance, the amount of gas required for a transaction to pass through is 500, and then you are having 250. Is going to fail. So that part of the execution client that checks validation is this is the part of the execution client that is in red for validation. So gas use needs to be less than gas, and then gas used is going to be checked after execution. Are you seeing this? Check that the gas limit is below the maximum allowed gas limit. So the reason why we need to understand this is because we're going to see how we can write a dummy execution client. And this is a good template. We're going to see a standard way of validating block within the red client. So this is a standard way of validating a block inside of the execution client. Yeah. So let's move backward. All right. So we have our RPC servers. This is where you connect your wallet. So we connect our wallets via the execution client, like any other client. The red execution client is also it also has its own RPC that you will connect with your external wallets, your EOA. So let's see where this implementation is in our red client. So we have the RPC type compact. So we have different implementation of our RPCs, different logic, but we are just sent to check this. Let's see. Let's see the validation. So the amazing thing about this is that there are certain engineers whose specialties is specifically to handle RPCs. Some engineers are having great specialties for handling RPCs. So the good advice we can give is you can dwell on an aspect. Just focus on an aspect. You understand the aspect. If it's to understand how RPCs work, then you stay there and understand how RPCs work. It's just amazing. Let's see what we have here again. So I did a short summary here. So for our node initializer, it starts all components, right? And then our networking connects to peer and receives transaction pools, validates and queues transaction, EVM executes transaction, state engine stores resulting state changes, consensus it validates block, and RPC it serves data to external clients. Now, this is just the execution client aspect, and you're seeing that there are different aspects in the execution client. So the reason why we're diving deep inside of the execution client is so that we understand that there are different components that you can focus on during this period of this workshop. So to some of you, you can pick the node initializer, understand how it works for the red execution client. When you understand how the node initializer work for red execution client, you can now go to maybe their GitHub repo, and then apply for an issue. Maybe they have an issue in the node initializer, and now you are in a better position to tackle that issue. And that's the reason why it seems as though when you go to a code base, you want to help out with an issue, it seems as though you are unable to do anything because the code base is just overwhelming. Now you need this workshop for you to understand each component and where to find each component in the code base. This is just what it means here for the execution client. And the execution client we use for this workshop is the ret execution client. So we've seen the networking part, we've seen transaction pool, we've seen EVM, we've seen state engine, we've seen consensus and RPC. So subsequently, we're going to be diving deep into the node initialization. We're going to go in depth into the code base. We're going to be seeing all the functions and what they do. And the next thing we're going to do is the networking. We're going to be seeing all of these things. But in today's workshop, I want you to know that there are different components inside the execution client. And for each component, you can focus on an aspect of the component to understand it properly. To understand the component properly. For further reading, you can go to the Red repository to see the full code base and just explore yourself. So this is the full Red code base. It's very, very amazing. I think I've been sitting on this code base for a very long time. Check this out too to be of great benefits to you. So this repository contains several raw scripts that implement the different building block of an Ethereum node. The high-level structure of the repository is as follows. General red is composed for a few components. So the main component can be defined as, so this helps us understand the workflow of the code base. So every code base has this. If you don't have this in your code base, then it's not a very, very workable code base. Every code base should have this. It will help you understand the workflow of the code base. So I added the links up just so that you can easily access them. So red production announcement. I hope this link is not breaking. Get updates. This is your website. Just to be updated with what's happening. How secure is red? Just this is just for your reading. This is just for your reading. And believe me, when you go through this, more insight will be given to you. Yeah, so I don't know if you have any question for me. Is there any question? Something that you're not clear with, and so that we can fall back to and explain. All right, seems like there's no question. All right, then we'll call it a day. So, like I said, the assignment I'm giving us is check into the node initializer. Go and do your research on node initialization. Check how it works, the flow, understand the code base. In our next workshop, we're going to explore that deeply. All right, so see you in the next workshop.